So after we've explained all that, what we're going to do is we're going to build a client server architecture. But we don't have a client just yet, but we are going to build a server. For the client, I'm going to use this program down here, which is called Putty. But we're going to build our server from here. So if you're playing along at home, you want to use Visual Studio Community Edition 2015. That's what I'm using. Select Visual C++ from there and then choose an empty project. And I'm just going to call this bare bones server. And I'm going to add a new item, which is going to be a main.cpp file. And I'm going to need IO stream. I'm also going to need another couple of things as well. I'm also going to add using namespace std. Now, of course, this is not a great idea. You can look this up on the web, but basically it's not a good idea to have this as a global using up here. But for the purposes of this program, it's fine. Void main. And then that's pretty much it. So the other couple of things I want to add is I also want to add the include file for WinSock, because Windows Sockets is the API, the framework that Windows uses to access network sockets. So the way I'm going to do that is I'm going to use the ws2 tcp/ip.h file. That actually includes the WinSock header file as well and a whole bunch of other functions that we're going to need later on. So it's best just to do that. The other thing I want to do is I can go in here and I can add the library file, but I'm actually going to use a pragma comment. And the lib I want to add, the library I want to add is ws232.lib. And I think that's all we need to do. Pragma. And that's it. So the tasks that we want to perform here, I'm just going to lay them down and then we'll start filling them out one by one. So the first thing I want to do is initialize WinSock. So we want to make sure that the WinSock is, that we actually have a connection to WinSock, because we have to request the use of WinSock. Any application that we do has to do this. And at the very bottom then I need to shut down WinSock. I want to create a socket. Now this socket is going to be the one that we're binding to, which means that at some point I'm going to have to close the socket down here as well. I then want to bind the socket to an IP address and port. Remember I said that one half of that tuple is an IP address and the other half is one half is the client side IP and port, and the other side is the server IP and port. Well, this is the server portion, so we need to bind the IP address and the port to that socket. We want to tell the socket, tell WinSock the socket is for listening. And then we want to wait for a connection. And then once we have a connection, there's a bit of a laundry list of things to do, but it's actually fairly simple. It's just like 10 things that we need to do. Wait for a connection, close listening socket, and then while loop, accept and echo message back to client. All right, so that's the things that we want to do today. Okay, so this is going to be our server. So we're going to initialize WinSock, we're going to create a socket, bind the socket to an IP address and a port, tell the Windows sockets layer that the socket is for listening, wait for a connection, close the listening socket, create a while loop that accepts and echoes messages back to the client, close the socket, and then shut down WinSock. Easy. Okay. So initialize WinSock. For brevity, I'm not gonna do much error checking here, but you really should do some error checking. So I might do a couple of bits of error checking, but that's about it. So the first thing you need to do is you need to call WSA startup. Startup requires that you have some data associated with that. So I'm going to have WSA data. I call it data. So this structure here is going to be filled in by our call to WinSock startup. And the way we do that is we need to request what version we want. Now we want version 2 point something. So I'm going to request 2.2. So the way I'm going to do that is I'm going to use word var equals make word. So that's going to give me version 2.2. And then I'm going to say WinSock OK equals WSA startup. And then I specify the word. So that's the version I want. And then I need to put in a pointer to my data, which means I need to put in the address of the data. So if OK is not equal to 0, C error, can't initialize WinSock, quitting. And then we're going to do return. Okay. So that's all we want to do. We just want to, if we can't build it, then we're going to fail. If we can't build it, if we can't initialize WinSock, then we're going to bail out early. Now the next step is to create a socket. So a socket is just an endpoint. It's matched up with a port and an IP address. That's what the next part is, the binding to it. So the socket is just this number. It's just a number. In Unix systems, it's called a file descriptor. A file descriptor is literally just a number. It's a handle. It's just I'm using 352, and I'm going to write things out to 352. And internally, 352 maps onto whatever device and whatever file and whatever thing it is. So yeah, that's what a socket is. It's just literally a number. But in Windows systems, it's given an actual type, which is socket. And this is our listening socket. And the way we create a socket is we call the function lowercase socket. And that takes an address family. So our address family is inet. We're using version 4, so that's why that is there. We want to open a TCP socket, so we're going to use sock stream. The other one is dgram. We're not going to use the datagram one. And then there's another flag there. We'll just do 0 for that. That's fine. Now this is where your listening comes in. Your testing comes in. So you might want to do something like if listening equals invalid socket, C error, can't create a socket, quitting. Return. Oops. So you might want to quit early at that point, and the rest of it I'm just going to leave as sort of for you to put in your error handling. But we're not going to worry too much about error handling from now on, because this program won't fail, I don't think. Okay, so the next thing we want to do is we want to bind a socket to an IP address and port. So we've initialized WinSock, we've created a socket. So the socket is just this nebulous idea of this is the reference number I'm going to use to access this port on this IP address. But I haven't bound it to that yet. I haven't said I want to link this socket to, or I want to link this IP address and port to this socket, so I can then use that socket to write out to that networking component. So really, it's not actually bind the socket to an IP address, it's more like bind an IP address and port to a socket, if you want to flip it on its head there. And the way we do that is we have a structure that we need to fill in called a hint structure. So the one we're going to use is this one here. So we're going to say hint dot, I've called it address, I don't know why. Hint dot syn address, let's do syn family first of all, equals AF inet, because again we're using version 4, hint dot syn port. Now this is backwards to the way that you think it is. I won't go into it too much here. In fact, I'll probably create another video that's got little endian and big endian, but basically networking is big endian and PCs are little endian. Now, in order to combat that, there's a series of functions that move between those two. And the one we want to use is htons, which stands for host to network short. Host to network short. And we're going to specify this port here. So port 54,000. I think we mentioned it in the diagram. So we're going to do hint dot address dot that dot s address equals, and then it's going to be in and any, because we want to bind to any address. I know this seems a bit of a kerfuffle. There's another way to do it. Could also use inet piton. We could also use inet piton, and we can bind it to the local loopback address, but actually that's probably better off putting it there, I guess. Could also use inet piton. Okay. So that's us filled in that. We then want to bind that to our socket. So we're binding this port on any address to this socket, and the command that we use to bind is called bind, strangely enough. So we want to bind a socket, which is listening. So we want to bind our listening socket. We want to pass in our hint, and we want to pass in the size of our hint structure. Now you notice that hint has got a red squiggly against it. That's because it needs to be this type here. And we also need to specify that as well. Whoops. Because we need to have the address of the structure, and it needs to be cast to be this pointer here. So it's just something that the bind function needs. Okay, so now we have the bind function. So we have our socket. We have the socket bound to our networking code. So now we can use that socket to reference the networking code, so we can send things out and receive things in all inside that socket. This is our file descriptor. If you've done any file stuff inside Unix, then you'll kind of know what I'm talking about here. So we want to tell the WinSock socket it's ready for listening. So we do listen. So listen just marks it as being for listening. It doesn't actually accept any connections inbound. So the socket we want to listen in on is listening, and then the background is SO max con. So max connections I think is like 15 or something, or it's massive. What is it? Yeah, it's massive. I don't even know what is 7 followed by like 7 Fs. I don't know. Big. So that's just the number of maximum connections we can have as a backlog, so they can stack up. And again, all this is handled internally inside WinSock, so it's not like we have to do much there. Okay, so I have notes to make sure I'm not missing anything out. Okay, so wait for a connection. So what have we got so far? We've got initialize WinSock, we've got creating a socket, then we have binding the IP address and port to a socket. So now we have that one half of the tuple bound to there. The next thing we want to do is we want to wait for an inbound connection. So we're going to create another socket address input, and this one's going to be called client. And we are going to get the size of that client. Size equals size of client. Because we're going to fill in some information about the client and then display that when we get the information out. So we're going to have socket, client, socket. Now, this is the part where we are listening for a connection, and a connection happens, and then that happens on one particular port on the server. So 54,000 is our listening port. The socket that actually returns this value here, this is going to be some other random number. Okay, so the client socket is going to be accept, and then we pass in the listening socket. So this is the socket that we're listening in on. So our socket that we're listening in on is bound to port number 54,000 on whatever IP it is. And we need to specify our sock address pointer, which is going to be our client. And then this is going to be the size of the client. So again, we're going to, at this point here, we're going to assume that everything's okay, but if you don't want to do that, then you should probably check if client socket invalid socket. Check that and then do something. Okay, but we're just going to assume that it's okay. So if we have a valid socket now, let's print out some information. So in order to do that, we're going to have to get some data from this object here. So there's a couple of functions that we're going to need to do. The first one is the get name info, and then we have another one called inet ntop, which gets the address and then converts that from the network address to a string of characters. So we're going to have char host ni max host char service ni max host, and this is going to be the client's remote name. Hopefully we can get the remote name. If we can't get the remote name, we'll use the IP address, but hopefully we can do a DNS lookup. Sometimes it works, it depends on the network. And this is going to be the service, i.e. port the client is connected on. Okay, so we're going to zero the memory of these. So host, and then the length is ni max host, and zero memory service ni max host. If you're working on something like a Mac or Linux, you can use memset and then specify the destination, which in this case would be host. The value would be 0, and then it would be ni max host. So same as that. So zero memory is just a define used by Windows, or provided by the Windows header files. I'm not sure exactly where it's defined. Where are we? Winbase. But if you wanted to make it portable, you would use that functionality. So just a little bit of information there. Okay, so this one is a bit of I've actually written some of this stuff down because it's difficult to remember all of the nuances of it. So this one, we're going to check to see if we can get the name information. And if we can't get the name information, we're then going to rely on the the information we can just get from there. So we're going to try and look up the host name of the client it connected to, and if it works, we get the host name and we display it. Otherwise, we're going to just display the IP address. Okay, so if get name info, and then we want to specify the socket address. So this is going to be sock address, and this is going to be client. And then this is the size of the client, size of client. And then this is the node buffer, which is host. And this is our node buffer size, which is ni max host. This is our service buffer. And this is our service buffer size, ni max serve. Actually, that should be serve. Whoops. I'll sort that in just a sec. And then that should be flag, should be 0 equals 0. Else, do something else. Okay, so that should be max serve. That should be max serve there. Okay. So if that's the case, then we can say cout host connected on port service endline. Otherwise, so this is us trying to do like a DNS lookup on the client information, and then we put the values inside host and service. If we can't get that, we'll display something. So we're going to do inet intop, and then we specify the internet family. So we want to get the IP address, which is going to be in 4 bytes. So it's going to be like 127.0.0.1. We want to get that back as a string of characters. So this is what we're doing here. So we're going to specify client.syn address, and then the string buffer is going to be the host, and that's going to be max host. And then we're going to do cout host connected on port, and that's going to be now this is what we want to do, is we want to get the network to host short. So this is the opposite of the one that we did up here, which is htons. So we want to do network to host short, and then this is going to be client dot port. So we're going to get the same-ish information, but this is just going to be the IP address and the port, and this is hopefully going to be like phrases that we can use. Okay. So now that we have that, we have something connected. So this is our client connected pair. So this is our remote IP address and port number, and our local to the server IP address and port number. That's what this client socket represents. So this is our connected socket. So now we don't need our listening socket. So we can do close socket listening. And I mentioned in the diagram video, if you haven't seen it, there's a link somewhere up here, that in other versions of this code that we're going to do, we're not going to close the listening socket. Once we receive that, we're going to keep that open so we can accept other clients, and we'll show you that how to do that later on. Okay, so I have char buff 496. I'm never going to be doing anything more than 4K, so I don't need to worry about this, but really you should be reading this until you can read no bytes. But I'm not going to do that for this one. I'm also going to just make it so that while it's true, we're always going to be doing this. So while it's true, we're going to zero that memory, buff 496, and then what we're going to do is we are going to wait for client to send data, and then we're going to echo message back to client. So we're going to wait for the client to send data, and the way we do that is we use the receive function. Receive function returns the number of bytes received, and if we get an error, which we're going to check, then we shouldn't do anything. And if we get bytes received of 0, that means that the client disconnected. Otherwise, we're going to retransmit that, and we're going to use the send function. Okay, so int bytes received equals receive, and then we're going to specify the socket. So our socket is our client socket, and our buffer is our buffer, and the length of our buffer is 4096, and we get 0 for flags. So if bytes received equals socket error, error in receive, quitting, and we'll break out of that. Otherwise, if bytes received equals 0, we'll break out if bytes received was 0. So socket error is -1. So if we receive 0 bytes, then we're not going to do anything else. We could probably do cout client disconnected. Otherwise, what we want to do is we want to send that information back, and the way we do that is we are going to do int send equals int. Do we need to know? You can check the errors here. It's exactly the same as this, but send will tell you the number of characters or number of bytes it's sent. So I'm just going to do send, and then we specify the socket. So we're sending this back out the socket. So this is client socket, and then the message is our buffer. Our length is actually bytes received +1, because when we receive a message, we don't get the terminating 0 in our message, but because we've done our 0 buffer up here, and remember I said we're not going to have anything more than 4K, bytes received +1 automatically sends our 0 buffer out, so that should stop any problems happening, and then we just have our 0 flag there. And then that's it. So we close, that's our echo message back to the client. Close the socket, so we do close socket, listen, client socket, and then shut down WinSock, which is WSA shut cleanup. So we should probably rename that clean up WinSock. Okay, I think we're good. So we'll compile it, make sure it compiles at least. Compiles, that looks okay. I'm going to run it once because Avast is going to kick in. There you go. It's nothing if not predictable. I need to figure out why this keeps popping up, because I did actually turn it off. Okay. Right. So it's now booted up. So now we go to PuTTY, and I am going to my local server here, which is 127.0.0.1, and then it's port 54,000. Okay. So I'm going to click on open. And you see that we now have Firefly connected on port 64916. Okay, so if I type in hello world, why are you not working, PuTTY? Well, it closed. Okay, so I don't know why Putty wasn't doing that. So I type in hello world, and then I hit return, and then I get back hello world as a response. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, and then backslash there. All right. Yeah, so that's it. That's a bare bones server.